China is the dominant force in EV battery production.
Climate action is the new buzzword, and why wouldn't it be? One world is all we have.
As the EV industry surges, one problem becomes even more apparent: battery prices. Batteries are the most expensive component of any EV, and so manufacturers have been searching for a cheaper, lighter, and more efficient battery. Today, more than ever, we're closer to that dream as the world's two largest battery manufacturers, CATL and BYD, have unveiled a game-changing sodium battery that has the potential to revolutionize the entire EV market. So what exactly is this new sodium battery, and when can we expect to see it in action? Join us as we take a look at this new sodium battery and when it's going into production. Before we go into the details, we need to understand some things about sodium batteries. When you take a glance at the periodic table, you might notice that sodium and lithium are neighbors, sharing similar physical and chemical properties. But did you know that sodium is over 1,000 times more abundant than lithium? Sodium is a key component of sodium chloride, or table salt, making it relatively easy to extract compared to the tedious process of mining lithium. Not only that, but the process of sourcing sodium is also more sustainable and environmentally friendly compared to mining lithium, which has significant impacts on the environment. Lithium mining in particular is notorious for releasing tons of carbon dioxide into the atmosphere, making it a major contributor to climate change. Moreover, the toxic chemicals used in lithium mining often contaminate the surrounding area, including our most precious resource, drinking water. It's clear that the environmental cost of mining lithium far outweighs its benefits. Another advantage of sodium over lithium is that sodium-ion batteries are easier to recycle and don't require rare earth elements that are associated with environmental problems. By contrast, lithium and rare earth elements are subject to massive shortages and price peaks, which make them an unreliable source for sustainable growth in the industry. Also, the price of lithium hydroxide has gone up from a mere $6,800 per metric ton in 2019 to a staggering $80,000 per metric ton today. That's an increase of over 1,000% in just 2 years. Meanwhile, sodium hydroxide remains below $300 per metric ton. Clearly, sodium has a huge advantage when it comes to cost. However, it's worth noting that lithium-ion batteries are known for their high energy density and performance, which is why they're commonly used in performance and long-range Tesla models. But there's a significant problem with these batteries: thermal runaway. You may have seen news reports about electric vehicles suddenly catching fire or exploding. This is a serious safety issue that sodium-ion batteries do not have. Because of these reasons, CATL and BYD decided to develop a sodium-ion battery. In July 2021, CATL revealed its sodium-ion batteries, which possess an energy density of 160 kilowatt-hours per kilogram, a slightly lower value than LFP batteries. While their energy density of 160 kilowatt-hours per kilogram may not be the highest on the market, these batteries offer a host of benefits that make them a game changer. Not only are they more cost-effective to manufacture, but they also perform exceptionally well in low temperatures and boast enhanced safety features. Now, CATL has even more ambitious plans on the horizon, with their upcoming sodium-ion batteries set to exceed an impressive energy density of 200 watt-hours per kilogram. And if that weren't enough to get you excited, these batteries are slated to hit mass production by 2023, marking a significant step forward in the energy storage landscape. CATL's first-generation sodium-ion cells are already impressively affordable, costing just $77 per kilowatt-hour. And with the second generation set to enter volume production, that cost is expected to drop to an even more jaw-dropping $40 per kilowatt-hour. It's fascinating how quickly technology can evolve and change perceptions. In 2021, many experts believed that sodium-ion batteries were only sustainable for certain applications, such as energy storage and two-wheeled scooters. Even CATL held the same view. Some analysts even speculated that CATL's sodium-ion battery initiative was merely a ploy to pressure lithium suppliers to lower their prices. However, as the development of sodium-ion batteries progressed and lithium prices continued to soar in 2022, the tide began to turn. It became increasingly clear that sodium-ion batteries had the potential to become a viable alternative to lithium-ion batteries in electric vehicles. In November 2022, CATL officially confirmed this development, announcing that their sodium-ion batteries were expected to power electric vehicles in the future. Last December, BYD also announced their plans to commence mass production in 2023 and introduce a compact electric hatchback powered by a sodium-ion battery pack. And now, at the recent Shanghai Auto Show, CATL announced that their sodium-ion batteries will be installed in the Chery iCar, which is set to hit the market by the end of this year. Similarly, BYD has announced that their sodium-ion batteries will be in mass production by the second half of this year, starting with the Seagull. This announcement came just in time for BYD's unveiling of the Seagull at the Shanghai Auto Show. The Seagull comes in 3 different versions, each with varying pre-sale prices ranging from $11,450 to $14,000. While the current models are equipped with LFP batteries, the new versions will use BYD's innovative Blade batteries, which have capacities of 30.08 kilowatt-hours and 38.88 kilowatt-hours. The most exciting part is that these new models will be powered by sodium-ion batteries, which offer significant advantages over traditional lithium-ion batteries. While they have some advantages, such as improved safety and cost-effectiveness, they also have their limitations, particularly when it comes to energy density. As a result, more sodium-ion batteries would be needed to match the energy capacity of lithium-ion batteries, making them less suitable for use in electric vehicles. However, the lower energy density of sodium-ion batteries is less of an issue for grid-scale battery storage. In fact, utilities can simply install more sodium-ion batteries to make up for the lower energy density without the need for additional space. The Inflation Reduction Act passed by Congress in August 2022 was aimed at reducing China's dominance of the lithium-ion battery market. However, a shift towards sodium-ion batteries may actually increase China's control over battery manufacturing. Of the 20 sodium battery factories currently planned or under construction worldwide, a staggering 16 are located in China, according to consulting firm Benchmark Minerals. This means that in just a few short years, China will have almost 95% of the world's capacity to produce sodium batteries, although lithium battery production will still dwarf sodium battery output. But despite China's dominance in lithium production, it faces a unique challenge when it comes to manufacturing sodium batteries. While China controls much of the world's lithium sources, it has limited access to the soda ash required to produce sodium. Interestingly, the United States is home to over 90% of the world's readily mined reserves of soda ash. Located beneath the southwestern Wyoming desert, this vast deposit of soda ash was formed over 50 million years ago and has been mined for centuries to meet the needs of America's glass manufacturing industry. The question now is whether the United States will leverage this resource to become a major player in the emerging sodium-ion battery market. In the end, sodium-ion batteries present an exciting prospect for the future of electric vehicles thanks to their incredibly low cost compared to their lithium-ion counterparts. In fact, sodium costs only a fraction of what lithium does, a mere 2 to 3% to be precise. This means that we could be on the cusp of a revolution in the EV industry as these more affordable batteries pave the way for cheaper, more accessible electric cars. But there's more to this story than just cost savings. One of the biggest challenges facing lithium-ion batteries today is a decrease in performance over time. This is where sodium-ion batteries shine, as they are largely immune to this issue. So not only could they be cheaper, but they could also offer better longevity and reliability. However, it's important to keep in mind that sodium-ion technology is still in its infancy, roughly where lithium-ion was a decade ago. This means that there's still plenty of room for improvement and refinement in the years to come. That doesn't mean it won't get better over time, but it does suggest that there are lots of things that can happen in the meantime. For instance, the price of lithium could continue to decline as new sources are discovered and the fruits of the IRA begin to kick in. As the race for sodium-ion technology heats up, it seems that the United States has a significant advantage in terms of its vast reserves of soda ash. But as the New York Times points out, the US is lagging behind China in terms of basic research and development for this emerging technology. The question remains, will America seize the opportunity to become a leader in sodium-ion technology and reduce its dependence on China for battery production? Or will it fall behind in the race for the next big thing in clean energy? Only time will tell. But one thing is certain, the future of batteries is shaping up to be a fascinating and competitive field. What do you think about this? Let us know down in the comments section.